Good morning. Happy Saturday, everybody. It's a beautiful Saturday morning here in the southwestern portion of the United States. I am Captain Coder, and it is Wake Up and Code 5 a.m. here. I've been up for about an hour, just getting myself together, did a little bit of reading. I just finished up my fall school term, so that ended. The last day of class was yesterday, and now I'm technically on vacation for 3 weeks, so that's fun. But we're gonna try to do day 17 of the Advent of Code. I think it's called. We've got this cool volcano showing up though. Check it out. Oh, that was neat. I never noticed if you click that that was interesting. It like lights up when you hit back. I've never seen that before. Smab, happy Saturday, my friend. I hope you're doing well. Hope you got some rest in. I hope everything's okay over there. We had some fun the last 2 days. These were some challenging puzzles. No worries, no worries. So it might be a little bit of spoilers for you if you don't mind. But I'm glad you're here checking it out. We are gotta set up my project space here first. Yesterday was super cool. Yesterday was like definitely a fun puzzle. Yesterday was hard. You got to know how to approach it. I did solve both parts. Second part, I had a slightly wrong approach initially because I was thinking, it's a pathfinding. It's a search algorithm. And you gotta. That one, I don't know if there is. You might be able to brute force the first part. You absolutely can't brute force the second part. Although a bunch of people did some hacky things with the second part. So after I solved it, I went and looked at what other people were doing. My initial solution takes about for part 2 is not brute force. It takes 90 seconds. It's essentially I think it's essentially a traveling salesman problem. So there's no quote unquote efficient solution to find an optimal path in traveling salesman problem. I could be wrong that it's not traveling salesman problem, but you have to visit. It's trying to find the most efficient route to visit like 15 nodes in a graph. Gotcha. Yeah, this is my first year doing Advent of Code, so I have no. I've done a lot of programming puzzles. I love puzzles. I have books with programming puzzles back before I knew about I used to only know about Project Euler, and then Leak Code and stuff started coming out. I did a lot of Code Chef stuff for a while. When I was in undergrad, I loved the programming competitions. Solution. The second part of the puzzle, you have like multiple agents. You have 2 agents searching the space with you on the second problem. So it's like a traveling salesman problem, but now you have two salesmen essentially. And my initial solution that I wrote was every step you would generate, each of those travelers would generate 2 travelers, so they'd keep splitting off. And so I was getting the wrong solution for a while before I realized, oh, I'm not even solving the right problem. But then once I did that, I solved it. That one was a big search space. It was like a 5-dimensional. The first part is a 3-dimensional puzzle. You can think of it as an array of 3 dimensions, and the second one, it's an array of 5 dimensions, or at least the solution I came through. Some people used their solution from the first part and just said, okay, well, this is the optimal way to open the valves, but you can create a degenerate case pretty easily that it's not necessarily the case that the order you open the valves is the best order if you have two agents. I won't talk about it too much because I know you haven't looked at the puzzle too much. So I apologize if I've given too many spoilers here already. I did find that the last two puzzles I didn't have too many people watching, so I wasn't getting distracted. And so I think I was able to. The distractions of talking with people does slow me down a bit and get my brain a little off, which is a fun challenge. They were fun. Yesterday's, there is no straightforward. I would say you have to know how to do all pairs shortest path. You have to know how to generate a graph and how to do all pairs shortest path. That's like the minimum. And then if you want to solve it efficiently, you have to. There might be another way to solve it efficiently. There might be some graph space trimming you can do, but if you use dynamic programming, you also, yeah. You have to, the search space is weird on that one. I don't think there's anyway, I'm glad that one didn't come up before my semester ended because I don't know how to put together a video that doesn't have to cover multiple algorithmic problem-solving strategies. So I have to do all pairs shortest. I haven't yet done a graph video, so you have to explain how graphs work. Then you have to explain how to do all pairs shortest path. Not just graph, weighted graph. Technically, all the edges are one, but weighted graph, all pairs shortest path, and then how to do set up a search space that is three-dimensional. It was anyway. Yeah, so like for me, it's funny. My partner, she is a software engineer, and this was the first puzzle yesterday. I think was the first puzzle that that I was going, no, I don't think your average software engineer could solve this puzzle without some extreme effort on their part to do some research on how to do these things. The only reason I can do them is because I've done these. I love doing these types of puzzles. So I look at the puzzle and I'm like, oh, it's this type of puzzle. So yesterday's was that version, and again, it truly is. I believe it's a traveling salesman problem, which has no. I think traveling salesman is NP. It's either NP complete or NP hard, and so there's technically no efficient solution to find an optimal path, but there's plenty of solutions to find a really good path. There's lots of efficient solutions to find a good path. Theory of computation was one of my favorite classes in grad school. Okay, let's read about pyroclastic flow. We're in a volcano, so I love this name. Your handheld device has located an alternative exit from the cave for you and the elephants. The ground is rumbling almost continuously now, but the strange valves bought you some time. It's definitely getting warmer in here, though. The tunnels eventually open into a very tall, narrow chamber. Large, oddly shaped rocks are falling into the chamber from above, presumably due to all the rumbling. You can't work out where the rocks will fall next. You might be crushed. The 5 types of rocks have the following peculiar shapes, where hash is rock and dot is empty space. So we have, well, they're not tetrominoes. They're not tetrominoes because they don't have 4 pieces. So they're not Tetris blocks. There's a couple. Didn't mean to resize that. Got a couple Tetris blocks. Then we have this special cross and a big J piece. The rocks fall in the order shown above. First the line shape, then the plus shape, and so on. Once the end of the list is reached, the same order repeats. The line shape falls first, 6th, 11th. Okay, so there's a cycle. This is our falling order from top to bottom. The rocks don't spin, but they do get pushed around by jets of hot gas coming out of the walls themselves. A quick scan reveals the effect the jets of hot gas will have on the rocks as they fall. Your puzzle input, for example, suppose this was the jet pattern in your cave. Okay, so left, right, left, right. Okay. Pattern means the jets will push a falling rock right, then right, then right, then left, then left, then right, and so on. If the end of the list is reached, it repeats. The tall vertical chamber is exactly 7 units wide. So this is Tetris ish. I love Tetris. It's one of my favorite. I've programmed it in probably 20, maybe not 20. I'd say 10 different programming languages. It's when I start learning a new programming language, usually the first thing I write is Tetris. Each rock appears so that its left edge is 2 units away from the left wall and its bottom edge is 3 units away above. Each rock appears so that its left edge is 2 units away from the left wall and its bottom edge is 3 units above the highest rock in the room. Okay, so that is how they spawn. That'll be interesting to remember. 7 units wide. After a rock appears, it alternates between being pushed by a jet of hot gas and then falling 1 unit. So it appears, gets pushed, falls. If any movement would cause any part of the rock to move into the walls, floor, or a stopped rock, the movement instead does not occur. Any movement would cause any part of the rock to move into the walls, floor, or a stopped rock. The movement instead does not occur. Okay, so the game state says, try to move. If I can't... So even moving left, right, any movement would cause any part of the rock to move into the walls, floor, or a stopped rock. The movement instead does not occur. If a downward movement would cause a fallen rock to move into the floor or any already fallen rock, the fallen rock stop where it is, having landed on something, and a new rock immediately begins falling. Okay. Drawing falling rocks with the @ symbol and stopped rocks with the hash, the jet pattern in the above manifests the following. Goes right, falls 1. Can't go right, falls 1. Okay. Yeah, that would be the rotation for Tetris pieces is tricky because where is the center of mass, right? So there's so you're probably right. But let's check it out. Okay, so we keep going, building up our world. Prove the elephants to prove to the elephants your simulation is accurate. They want to know how tall the tower will get after 2022 rocks have stopped. Okay, after 2022 rocks stop, but the 2023rd, but before that begins falling. In this example, the tower will be this many units tall. How tall? Okay. This is fun. I like this puzzle. This puzzle is a nice detour from our nightmare, from people's nightmares in the last 2 puzzles. I didn't think the puzzle from day 15 was that crazy. My brute force solution finished in a second, like 2 seconds. But I guess I had to build a special setup. Oh, and I did end up doing a quad tree thing, which is, it turns out a quad tree is pretty straightforward on it as well. I was thinking I had to do a diamond-based quad tree, but you don't. You just have to, anyway, I won't go into too many details on it. You can do a regular quad tree and you say, hey, does this space exist inside? So you have to write like a special contains method on your sensor grid that uses a quad tree, and then you say contains. You write a contains method that says given a rectangular shape, does it contains it, And then if it doesn't, you have to, as soon as it finds something that doesn't, it reports that position. So there's a pretty efficient solution there. Okay, that's not brute force. Let's make a piece record, and the piece record basically is going to be a set public record. I'm thinking of it in terms of Tetris, so and it'll have a hash set position, which are like offsets from the top right, I suppose. Is that what I want? I think this is what I want. Rocks. And I gotta create a position type. Int row, int column. And then we'll define our positions. We have public static piece h line new equals new, and then we'll give it a new hash set, and we'll fill that up. It's gonna just be new position 0 0, new position 0 1, new position 0 2, new position 0 3, like that. Cross 0 1 1 0 1 1 1 2, new position 2 1. And that should give us our cross piece. We'll call this a J. This is going to be 0 2 1 2 2 0 2 1 2 2. We'll call this our B line, and we just go top to bottom 0 0 0 1 0 2 0 3 0, and then we have a, we'll call this O. It really doesn't matter as much. I'm gonna call it H X J I and O. 0 0 0 1 1 0 1 1. There are my pieces, and then we're gonna get public static 1 1 enumerable of piece, and it's just going to loop forever. Pieces. while true. I bet there's a cool repeat pattern thing I can do here. Let's do piece, position, pieces, equals, new, H, X, J, I, O. I gotta put brackets here, right? Okay. Pieces dot. Oh, there isn't a repeat. That's too bad. I thought I could do a repeat. And there might be a repeat there that I'm just not aware of. All right, we'll do a while true. For each piece in pieces, return yield. Is it return yield or yield return? Yield return. Try return yield P. Yield return. Hey, there we go. So we got an infinite generator for our pieces. And now we're just gonna keep a whole set, and then simulate the moves. So we'll create a new file called board. Public record board. And this is gonna have a hash set of position. Rocks, and then it's gonna have another thing that changes. Public piece falling, get private set, public. Actually, let's do this the fun. Every time I do this, let's do this the fun functional way. But I think we can. We'll have a piece falling, and then that piece has an offset. So position offset. So like the rock is falling, and it has an offset, and so we need our piece. Okay, so our piece needs a method for applying left and right. So we'll have public piece shift, and it's gonna take a this interesting. Do I want the piece to shift, or do I want the board to do the shift? That's the question. Let me think about this. I have the piece shift itself, or know how. So this will shift, position, offset, and this is just gonna give us back this with row equals this dot row plus offset dot row. Oh, it's a whole hash set. Ugh. Okay. Let's add in this maybe isn't the best. Maybe I shouldn't do this functionally with records like this, but let's do this. Shift, position, offset. This one becomes this with, I don't know if I save much by doing that. This step, new position, this dot row plus offset dot row comma column plus offset dot col. Do I like that? Oh, this needs to return a position. Do I like that better than this with? Yes. Yes, I do. Unless I can do this with row plus equals offset dot row. Can I do that? No. All right, I think I like the way this looks better. All right, so now we can shift our position. And shifting a piece is the same as shifting all of the positions. So we'll do a hash set. We'll do this dot rocks dot select P goes to should just be position not quite. P goes to P dot shift offset dot to hash set hash set position new pause, and then we'll just return new piece new pause. All right. Okay, so we have our shift, so our pieces can shift around, and then our board has a piece that's falling, so we can sort of update our board. We're gonna have a lot of copied boards, I think. Is there an efficient functional board, or am I gonna be dumb and copy all of the positions over and over? Let's be dumb. We'll copy the positions over and over. Okay, so we're doing the functional version, which is interesting. So we're gonna have a public board shift position P, and it's just gonna return a new board if possible. It's gonna say if falling. Yeah, so we're gonna get piece P try piece equal falling dot shift by P, and then we check, can that piece go that direction? If the piece touches anything in the hash set there. I only care about like the top row. This is wholly inefficient because it's gonna grow massively. I kind of want to keep track of just like the top row as well. So really all I care about is the top row, or the top couple of pieces. Let me think about this momentarily. This would be a very inefficient way to do it. I'm gonna add a comment here. To do, consider keeping rocks in a Oh, I don't need to check all the positions. Here we go. I just need to check all the positions in the falling piece. My brain was thinking I had to check every position here. All right, that's the whole reason we use the hash set. The whole reason we use a hash set is so that we can do for each position P in our try piece dot rocks. Call this offset for each position in our attempted move if rocks dot contains B, we can't do that move, so we just return ourself. And if we get all the way to the end here, we return this with falling equals try piece. Otherwise, we move it. The equivalency check there is not. So when we move down, I'm actually going to change this to return a bool, make this try shift, and have a outboard update. No, you don't, because the this piece here, you have overhangs. So you're right for all of them except for this piece. So I've done Tetris. I've written Tetris enough that you actually have to care about this piece. You can have weird situations where you have two cross pieces sort of intersecting with each other. So you have something where it's not just the bottommost piece. So you could have overhangs where you get caught on something, at least with this piece. So if this piece is coming down on this, you need to check the left piece, this arm here. And then with rotations, it gets harder because this one has 4 empty spaces. Yeah, you only have to check the 3 points on that space. You're right. You don't have to check them all, but you have to check the ones that it's possible. I only need to look for pieces on the underside of the shape. Oh, sorry. I misunderstood what you said. I thought you were saying you only have to check the bottom row of a piece, not the last position. Yeah, so that's what I was just mulling over a second. Dota, happy Saturday, my friend. It's so nice to see you. I haven't seen you in a little while. Yeah, I was thinking I should keep this in an array rather than a hash set, but I believe this should be fine. It's gonna return false. And update equals this. And then update equals, and then return true. Dota, I haven't. I've been so I just wrapped up my semester at the school I teach at. I've been I've created a bunch of work for myself is essentially what happened. So I was planning to, and then I learned about the advent of code and got super excited about using it with my students. So I was rushing to get all of this together to do stuff with my students. But yeah, I wanted to, and I just never quite got around to it. So I apologize. I didn't get a chance to check it out. But I still want to. It's sort of on the back. There's not enough versions of me / not enough hours in a day for me to do it. Yeah, chess is like an interesting thing to write. Trying to model it in a way that is efficient is tough. All right, so we got try shift. And then, oh, I do need to keep track of the highest point position highest point so that I know where to spawn the next rock. Yeah. So I do need to keep track of the highest point. So we sort of have this try shift, and then I have a public void set piece. No, the public board set piece. Which takes the current falling piece and adds it to the board. So this should be rocks.union with falling.rocks. So, and then we got to update our highest point. Oh man, Dota, I want to look at it so much. Because it was such a fun thing to do. I'm planning, like I said, I want to make a chess program, a project to make a chess, not an exact chess game. I actually want to do a chess puzzle game, so like a subset of chess, as a project for my students. And so I would love to look at it, see what we can do. Yeah, so there's this cool game I have. I don't know if you can see here my videos back, or this game Solitaire Chess, which is on a much smaller board, and it's a puzzle game where you have you don't use the queen and you don't use the king, but they're these logic puzzles of how to solve it. So I want to create a project for my students to solve. First, to implement it as a game, and then write a solver for it. So the solver is actually really, really cool. I'm pretty sure you can do a solver not without too much difficulty because the state space is small. So we can use various techniques. We can do a brute force technique, and then we can talk about building a graph to solve it for some of my more advanced students. So I do want to look at it because I want to figure out a nice way to model both a chess board with chess pieces, because the pieces in the board are sort of tightly coupled together, so it's interesting. It's an interesting challenge to say, should I model them separately? And so I think the way I want to do it is the board and pieces are one thing, and then you have the piece logic happens to be a class. So there's a class called piece logic, which given a piece, like a position on the board, can determine stuff, because the pieces don't actually care what the other pieces are. So every piece will then have just sort of a logic attached to it. So I think that's how is the way to do it. And then the board and the pieces are all coupled together. Next, rocks. This with, well, we're gonna have to update everything new, so we're gonna have to get a bunch of new things. Piece next falling equals piece.j for now. This will need to take in an I enumerable of piece q. Be q dot next. Does I enumerable allow us to do it like a next thing on it? We'll see. We'll see. I'm gonna do something like this. I might even be piece next. That's what I'll do. Cool, man. You know me. I'm a programming language slash compiler. I wouldn't say guru, but nut. I think they're fascinating. So building interpreters is super fun. When I was in grad school, it was just like something I'd do on the side. I really enjoyed doing it. New board. Next rocks. Next. Well, we're gonna have to shift it and then new highest. Next. Highest. What is this complaining about? Oh, that's a void. Yeah, I don't want to do that. Union produces the set of the union of two sequences. Dot. This is bad. Smab, if you're watching, is there a nice immutable hash set type in C# or set? Doesn't necessarily have to be a hash set, but an efficient set type that is immutable, that I don't have to do this. And then we get our highest point here. I'm gonna be in trouble for part 2, I can already tell, just by the way I'm building this. And then we want to get the highest point, so position next highest starts out as highest point, and then we do for each position P in falling dot I won't worry about it for now. I think so I actually suspect this is really inefficient, and if I had an immutable version, there'd be a fast immutable union that because they're all immutable, it sort of can use a lens on it. I'm gonna stick to this just for now, but am slightly regretting it. Rocks. Then the one with the highest. Beautiful. See? Beautiful, my friend. Thank you. I'm going to save that in case I need it. I may not need it. But this is gross. I don't like that at all. P in falling rocks. If P dot row greater than next highest dot row, next highest equals. That makes sense. And when I'm doing C#, I'm usually not doing a lot of immutable stuff, but there's a lot of niceties when you do immutable stuff. Specifically for testing. Testing becomes so predictable with immutable classes. Equals P. I could use a link thing here to find the max. This is fine. Set piece updates the max to the highest point. Next piece isn't quite right yet because I have to shift it. All right, once we know what the highest piece is. Hang on, let me in my piece. Public position highest. Public position lowest. Public position left is. I kill myself. Alright, we'll do this. Highest. For each position. This one we can do return rocks dot max of p goes to p dot row. Oh, is there not a max like that? Order by. Yeah. I caught it. Does max? So I would, Dota, do you think it get more out of coding an interpreter or a compiler? I would say interpreters you can do much cooler things more quickly with interpreters. Compilers, don't necessarily you don't necessarily need to know assembly to do it, but it's good to have a solid grasp of assembly to do a compiler, because you end up building out, you have to compile it to something. Transpiler, a little bit easier. I always recommend doing interpreters because they're way more fun, in my opinion. Compilers are super cool, but like the math part of compilers and optimizing, they're quite different to do. Do I have to do A, B? Hang on. Let's look at max. What are my options for max? Comparer. Well, but then I want to return the position. So if I convert it to there, I'm gonna do an order by. Yeah, I need to be able to turn it to an int. Okay, so I'm surprised I can't do p goes to p dot row. Cannot convert type int to position. A, B goes to A dot row minus B dot row. Is that what it wants me to do? Yeah. Here. I'm gonna be dumb. Order by. P goes to. Wants me to implement. I really want to use this max, and so I'm just gonna force myself to learn it. All right. C# link max. Let's make myself learn it. Let's make myself learn. What is it asking for here? Invokes a transform function on each element of a generator and returns the maximum resulting value. So that's what I was doing. It was transforming it first. Oh, I see what you're saying. I don't actually need. I see what you're saying. I don't actually need to know the whole position. All I care about is the highest point on that position. Yeah. p dot row. Same with this one. Rocks dot min p dot row, and yeah. Rocks dot min p dot column. I understand that. So in my brain, I wanted to, and if I really want the position, yeah, if I really wanted the position, I could keep it in there, but I don't care about the actual, I only care about that int. So thank you for that int highest point. Gonna have to be a whole position. Yeah. So that worked out. That worked out all right for me. Okay. Next highest point. Because for spawning the next piece, I need to shift it by its left and lowest up, right? So next highest is going to be math.max of highest point and falling dot highest. This doesn't need to be a method. Well, it's a getter. It can be a property. There we go. Next highest. And then my next piece is going to be next equals next dot shift, and then the amount we're going to shift by is a new position. I'll do left shift bottom row shift call shift. So we have int row shift is equal to so how far we need to move it up is going to be highest point. So shift it up 3 above the highest point. Well, we need to get our lowest, right? So our lowest, let me double check that it's not shifting up just by 3. It's the the rocks. The rock appears, each rock appears so that the left edge is 2 units away from the left wall. And the bottom edge is 3 units above the highest rock. Yeah. So it's gonna be, I need to get the lowest, so falling dot lowest. No, next dot lowest. That's going to be the lowest point on the piece that's coming in. And then the next highest. So it's next highest plus 3 minus next dot lowest. Is that right? Let me think about that. So the next highest, I need to move up 3. And then if I might have to draw this out for my brain to be able to have it. No worries on your lag. Not a big deal. I can reason through this. I just got to draw it out real quick to make sure my brain can handle it. I'm getting my drawing pad here. I need to just need to visualize it. Not all of us are superhumans and can do the visualization in our heads. I wish I could stay on the camera while I did it, but I got my drawing pad sort of over to the side here. So let's imagine I have a falling piece here, and the topmost piece is over here, highest. I need my bottom piece. Do I have a dock cam option? Do I have this set up? I don't think it's gonna. I think it's gonna be all blurry, but we do have a dock cam here, so we can sort of talk through it. But getting this to focus sometimes is a nightmare. All right, so my highest piece is here. So this is some y. So it's gonna be the y position. So this piece, its bottom, in this example would be 1. No, 2. 2. Oh, what's interesting, and I didn't think about this, is I have defined these 0, 1, 2 coming down. So my highest is actually going to be a negative value. So alternatively, I could, because I think in rows, right? So I like to think rows going down, rows descend this way. So when I add these in, the bottom piece here, so I'm thinking I might have to, yeah, I'm glad I drew this picture because it's gonna, because really, I want, if I'm going like this, my rows need to be going up rather than down. So I should probably update my code to do that. So my P, this one's fine, but this one, technically this one is fine too, because it's just an inverse. My J piece is fine. This row should be 0. So I might actually want to switch my position to be row and column. Or sorry, X and Y to make my brain. Because this row is higher than this row is what I'm doing now. But yeah, this would be 2, 1, 0, 0, 0. If I want my rows to go upward. This one should be fine. My O. So this one's the only one that actually would cause me problems. So, all right, I think I'm okay there. Okay, so let me work through this again. Let's see, can I switch that? It always gets fuzzy each time I switch it, so now it's gonna be fuzzy again. So let's think here. I wanna work through. Yeah, so my coordinates in the chamber, I probably should just done X and Y for my brain. I wasn't. Anyway, it doesn't matter that much. So we got 0, 1, 2 is the initial position. And the highest position on this, let's say, is, 100. This needs to be shifted up. This should now be at 103. 103 should be this bottom position. So it should be highest plus 3. Well, now I've defined it actually, so the lowest position on all of my pieces will be 0. So I just need to add in 100 plus 3 should be my Y shift, I believe. Cool. So, yeah, when I drew it out there, I think I'm okay. I think all I got to do is highest plus 3. should be my shift. Now when I print it, it'll be crazy, right? So I probably made a terrible mistake. Left shift is going to be my next dot leftist plus 2 call shift. Once what did it say here? The rocks 2 units away from the left wall. Okay, so I should increase this and that. All right. Okay. So I actually don't think I even need the bottommost of it because I've defined it so the bottommost index, the bottommost row on all of these is 0 by default. Okay, so I have my shifts, I have my set next piece. I kind of just need to have, oh, I guess I got to parse this in, right? So, public static IEnumerable of position parse jet stream string row, and we're just going to iterate over all of them while true for each char ch in row. If ch is right, or here we go. We'll do a yield return ch switch. I like that I'm getting better at these pattern matches. I hadn't done a whole lot of these pattern matches before. My students, for the most part, we stick to the ifs. So we're gonna say if we're going to the right, this is gonna be new position. Increase 1. This will be new position. Decrease the column. And then this would be throw new exception, cannot perform, cannot parse jet stream char ch. JetBrains products give you pattern matching when necessary. It highlights the block and lets you. That's cool. That's cool. I like that. Okay. So we have our jet stream parsed in, and so now it's sort of, we alternate moving and dropping a piece, right? So we are going to public board step. So a step is a move and a drop. So given a my board, I need like an iterator here. Can my enumerables, it needs like a count of pieces as well. All right, I'm gonna create a new file here called new file simulator, because I want to be able to, I don't want to have to think too hard about this. So my simulator is going to do all the work. I'll move my jet stream over to my simulator. Public. I'll make my simulator a class. I can still make it a record actually, which is kind of nice. But the board's going to be changing, so I don't know that we'll make it a record, but it's going to just have like these properties: public, board, board, get, private, set, public. Before I lose this, parse that in there. Public iterator. Is there an iterator type? Because the enumerable public. I've never written Jetstream. Get private set, and then we also have a public enumerable piece piece queue. And this is just gonna be initialized to piece dot pieces. This is just gonna be string input, and this will be initialized to our parse Jetstream inputs. Okay, so a single step. Formal Goose Foundation. Happy Saturday. I'm happy to have you aboard. Yeah, it's nice. It's always nice to meet new people, have people in here watching me sweat a little bit, work my way through some coding problems. How are you doing, my friend? Public. Of course. You're welcome to lurk. You're welcome to learn. I hope you learn something. My goal here is to try and help people learn, but also to learn myself, learn and grow myself. I'm gonna throw out there that I am definitely not a C# expert. I do think I'm pretty good at this whole programming thing, but I'm not. I absolutely need help. So. Yeah, that Smav, that was my initial thought, was like, oh, I'll use a queue and I'll make it a circular queue, right? But the IEnumerable was fine. It is just a piece queue though. You are correct. You are correct. Public void step. Yeah. That's essentially what I'm doing, right? So when I implement it here, I'm just like, well, true, just keep on going. Just keep on doing it. The modulo one, technically, if you're doing the modulo, your integer. I don't know. I was gonna say technically your integer might get some overflow eventually, but you could do it with that, so that wouldn't occur actually. So it doesn't matter. What is the method to pull a single thing off an IEnumerable? I actually don't think I want an IEnumerable, right? I want to get the IEnumerator. Yeah. This is really what I want. Keith would be so upset. These say get enumerator, not just enumerator. So now I can just pull a single thing off. So I could do. So in the jet. So okay. The order is I jet stream first and then fall down one. All right, so a single step is I parse my jet stream. So position offset equals jet stream dot move next. Oh man, I'm not familiar with how this works at all. Gets the element collection at current position of the iterator. Yeah, I could throw some link in formal Goose Foundation. Does this advance the iterator? No, the jet stream is infinite. So if you try and turn it to a list, I want to do a single step. Here the thing is, I want to do a single step, but I want to iterate the whole thing. So this is actually an infinite iterator. It goes on forever. So turning it to a list, I think will cause it to explode, to end. I could be wrong. Because I want to do a single step here. Yeah. Offset. So board dot try shift offset. Outboard. This dot board. Oh, I'm missing a comma. Property or indexer may not be passed. A property or indexer. Interesting. All right, so board next board equals board. Well, really what we're gonna do is if we are successful, update. This dot board equals update. All right, so I'm gonna pull a thing off. If we can shift, we update our board. If we can't shift, we do nothing. The board doesn't change, and then we move it down one. So then we say if board dot try shift new position -1 0. So we're gonna try and go down. Board update. If we are able to, do I not need to? That's interesting. I imagine. Apparently, I don't quite understand scoping here. I would assume that this would only be scoped to here, but that's okay. So if we update again, this dot board equals update. If we can't update, we set the piece. So it'd be this dot board dot set piece. And we got to get the next piece, which happens to be a piece Q dot current. So I just need to know whether or not this updates, gets the element in the collection at the current position, the element in the collection at the current position of the enumerator. Does that update it? Does that move it? Does that iterate it? Let's go to our program here. Piece, or I'm gonna do it real quick here. If I do current, this should be simulator, and then my string. Okay. I do console.writeLine jetstream. Well, let's just alternate here. Right and left. Jetstream dot current. If it does, returns null. What? Current. Or int I equals 0, I less than 10, I plus plus. Let's see here. Turns null. I'm amazed. Or is it that my position prints really badly? Console.writeLine. Oh, I think it's that it doesn't progress it, so I have to actually progress it once first. Move next. Advance the iterate to the next. All right, this is okay. So this answers my question. That I actually have to do move next. All right, so in my simulator, I'm gonna do jetstream.move next, and then piece queue.move next. All right. So it sets the piece, and I have to count the number of pieces I've set. So public int set pieces. Starts at 0. Yeah, then we do set pieces plus plus. Okay. That's, I think, I've written no tests, so I'm probably gonna run into something. But I think I have all the logic worked out for moving things around. As usual, hopefully none of my students are watching, so they shouldn't know. String jet. Load this example in real quick. And then we're gonna do a simulator s equals new simulator jet. While s dot set pieces is less than 2022, s dot step. All right. Console dot write line s dot board dot highest. That should be our solution. Unhandled exception. All right, cool. Object reference not set to an instance. What is my board initially? Okay, so that makes sense. That makes sense. Private board init board. If board can we call a net board here? Because this doesn't exist yet, right? So I can't call a net board. Private. Oh, maybe I pass an initial board in. Really, I want to say if board is null, we're gonna initialize it. by doing and then piece falling equals piece q dot current, and then board equals new board new hash set. Oh, am I doing the hash set right? Yeah, I am copying it. This is why I wanted the immutable hash set. My falling piece would be falling. Well, we have to calculate it. Dot shift. I need to shift it up 3. New position 3 0. Falling, and highest point is 0. All right. And this is dumb, but we'll init the board. This only inits if it hasn't been initted before. And see if we have an off by 1 error. Oh boy. Oh boy, that's slow or not working. Okay. Move next. All right. All right, I think I need to... It's just slow. I think it's just really slow. I've done... My approach is probably very slow. All right, I'm gonna write a visualizer for my board. Public void print board, so I can print it at every step. And start at my highest point and work my way down. Well, int. I also don't actually check. Okay, so I'm only checking if it contains that position. I'm not checking the left and right side. Yeah, so I need to make sure I check my left and right side here. Or p dot try piece dot leftist is less than 0, or try piece dot rightist is greater than 7. All right, let's add in here right. Yes. All right, so I definitely had that bug in there. But I still want this print. So we're gonna say for int row equal to this dot highest point. Really the highest point of this or this dot falling dot highest. So do int top equals. I'll just put it 3 higher. This dot highest point plus 7. So my tallest piece is 4 tall, so plus 7. Otherwise, it's gonna do a weird thing where it's like shifting on me. So we'll do highest point. Top row is greater than or equal to 0. Row plus plus. So we're gonna go down from the top and then 4-int column. Oh, row minus minus. Column equals 0. Column less than. It's 7 wide, right? 7 units wide. Yeah. Less than 7 doesn't really matter, I suppose. Call plus plus. And we'll say if console.writeLine, and then this will be if rocks.contains new position row column console.write a hash, else if falling dot contain falling dot rocks dot contains, let's make a position p equals new position row column p. If our falling piece has it, console dot write an @ sign, else console dot write a blank. All right, so now I can print the board at each step. So we'll do s.board.printBoard console.clear, and then why is this auto completing so weird? Maybe my hands, I'm just getting too excited, and we'll wait for me to press a button. I suppose I should output that information, but we'll be a little lazy just for now. All right. I can't print it until I've done a step. All right. That's fair. There's my piece. Moves to the right and down, right and down. Oh, it never hits the bottom. It never hits the bottom. Okay. Okay, some silly dumb things here. Simulator step board. So it just had an infinitely falling piece there. Let's see, try piece. If we'll do this one last. And we do try piece dot lowest less than 0. This is when we fail, right? Oh, and I don't need to. I did forget to put the floor in. All right, so I don't need to do this check every time. This one just becomes. All right. I've written this in such a silly way here. Or oh, I do want that. Return false. All right, this looks horrible. Yeah, I forgot to put the bottom in. All right. Let's try that again. Why is that? It's just floundering there at the bottom. I'm not getting... the next piece. Let's look at my simulator. If I can shift... this dot board equals... there we go. My immutableness getting me. All right. Now I think we have it. Let's see here. That's supposed to land. All right, so something... it's not landing quite right. Let me print out dot on my board here. I'm getting close. Unit test would have caught all this. So I move right. Let's start over. The first rock begins falling. It's not high enough. Which is interesting to me. Starts... okay, so... okay, so why... and then it will land. Alright, I still have something wrong. Shifts over and then goes down one. Well, I have it checking. Well, I don't think I'm starting it. Here, let's see what I'm printing. Good point. Let's see. I'm printing the 0 at... it is at 0. So I'm considering my floor at -1. Yeah, so my floor is at -1. When I try to shift, if my lowest is less than 0, I can't go there. So yeah, -1 is my floor. So it should go right and fall 1. It's starting shifted incorrectly as well. So if I look at my picture here, do I have 7 across? 1, 2, 3, 4, 5, 6, 7. I'm just not... for some reason, my brain is not increasing. I don't quite understand why this... oh, I didn't start it shifted over to... my start is incorrect as well. I need to... this one should be 4. And this one shouldn't necessarily be 2. It's going to be like int call shift equals piece first equals piece dot q dot current. I need the leftmost. Oh, shouldn't I be able to just do 2 here always? That's interesting. I should always be able to do 2 there when I place my piece. No. Why? I'm so confused as why it should be 1. Landed in the right spot, but it went off the edge. Why am I shifting by 1 and not 2? I don't understand that. Alright, so set piece in my board should get me the next piece, and my column shift +1, it sort of looks like. No, it's +2 there. I am going off the edge. The rightist is greater than 7. Console. Oh, don't understand. I'm like slightly confused here. I gotta take a quick drink here, see if I can let my brain slow down just for a second to really think about what's going on here. If my lowest is less than 0, my leftmost is less than 0, or my rightmost, and what am I doing for rightmost? Take the biggest column. Let me rename this rightmost, leftmost. Fascinated that it lets it go off there. I think I'm gonna break this into 2 things. Step, jet, public void, step, ball. And then I'll have a total public void, step, jet, step, ball. Just so I can try to reason about it. Board. And then in my program, step jet, I'll do s dot to make this public. If I made this a class, I wouldn't need that. What's this? Okay. Init board. S dot step jet. Print it. Step ball, so I can see exactly what's going on. Step ball. And here I'm I'm gonna make jet return the position that the offset it did, or attempted. And then the fall is always trying to push down, so it's not important. But just so I can see. Console.WriteLine attempt. And then just for console here, just for consistency, I'm going to add in a console.WriteLine. Okay. Okay. So I was starting in the right spot. It's just the initialization was messing things up. Okay. So I need to, in my init, this should be 2, and this should be 3. Because I was calling step 1, so it was making everything go down 1 by default, so my brain couldn't handle it. All right. So we go right. We go down. We go right, which shouldn't work, but it lets it work. So why is it doing that? Try shift. We're trying to shift by this. Okay, well, let's... I need to print out. I need information about what the rightmost is. Let's get rid of these clears, and we'll add in some extra right lines to give us space in between them. Oops. And so we can see them separated, but I'm going to add in some print line debugging. Not the best, but I need to know what the rightmost position was. Console.WriteLine try piece try piece dot rightmost. The rightmost was 6. I dropped one. Oh, because I indexed by 0. Okay. That makes sense. 0 to 6. All right. Okay. That still isn't right. All right, let's look at that. So this is taking way longer than I thought it would. I thought I'd be able to get this part quickly. Rock begins falling, goes right. Goes down. Goes right. Goes down. Goes right. Goes down. Goes left. And sets. A new rock appears. It's not high enough. Okay. Oh. Is it left enough? It is. The bottom. Yeah. Okay. Is my L. Yeah, so it needs to be 4 above because it needs 3 spaces in between. Off by 1 errors. Because I'm good at programming. Okay, I think I got it. I think I got it. Okay, this is looking good. Let us s.step, which before I get too excited, let's make sure my s.step is gonna work. Read line s.step. Let's make sure this still looks right here. It should. All right. Okay, I feel good about that. Let us call step and get the highest point. Ooh, let's remove our prints here. $30.67 off by 1. For some reason. Oh, because I start at index 0. Yeah, so this would be a height of 1. So yeah, it's off by 1. Because of the way I'm storing the highest point. The bottom row is position 1. So let us get our... Ooh, that's a big old jet stream. Okay. Input. Jets equals file.read all text input.txt.trim. Hey. All right. Smab, if you don't want to see the part 2, now was your chance to step away. Now's your chance to step away. And I know there's a delay, so I'm gonna go grab myself a second coffee real quick before I start part 2. All right, I'm back. Um, yeah, the first part's trivia. I'm a little embarrassed about how long it took me to complete. Um, okay, part two is pretty short. That's not a good sign, or maybe it is. The elephants are not impressed by your simulation. They demand to know how tall the tower will be after. Whew, million, billion, trillion. After 1 trillion rocks have stopped, only then will they feel confident enough to proceed through the cave. Okay, so no rotations. No rotations. But we have to be able to run our simulation 1 trillion steps. This interesting. So there must be there has to come a point. So the only, so if we know these always come in it. Yeah, so you have to find a cycle. So if there's no cycle, you're screwed. So there has to be a cycle, right? So we have to find where our input. So our input has an order, both the jet stream and the pieces come in at a known sequence, right? And so that sequence is going to have a cycle in it. So we need to detect. So there's a couple things we could do. I think we could detect the cycle without building anything and then find where that cycle starts. So we want to ask the question, when does the pattern repeat itself? And so what we can do is we can overlay our pieces. So we have two arrays, essentially, two iterators, and we just keep overlaying them until we find the sequence that repeats in that. But, and then we have to, is that how we want to do it? But yeah, there's going to be an overlap where the sequence just starts repeating itself, and you say, okay, well, how tall is that? How tall was I when I got to that repeating sequence? Well, I'm not sure if that will actually work perfectly, because even if yeah, essentially you're right. But are we guaranteed that the pattern of that's going to match our board state, right? So our board state comes in, we always start 3 above. I think it may be even worse than that. Yeah, so ooh, that's a good way to approach it. Okay, all right, so that's a good way to approach it, is we can actually, each time we set a piece. Yeah, no, it's lagged. Each time we set a piece, we can basically say, okay, has this row repeated before? Right? Has this row repeated somewhere before? So we have a hash set. We have a hash set of rows that exist, right? Yeah, so we're gonna have a hash set of rows, and we say, have we seen this row before? If so, have we, does the pattern? Yeah, but what we care about is that is the row are the rows the same? So we have this hash set of rows. So the row being 7 wide helps out greatly reducing the space. You say, have I seen this row before? And if I have seen this row before, have I seen the row that comes after it before it? And so then you go back and you say, okay, well, now I know what are the possibilities that came after this row, until you get a row. So you build up your sequences of potential patterns until you find it. Yeah. So I think this one's not too bad. Yeah. So you have a graph. So the way I think of it is I have a graph, and every node in the graph. So here's my thought. Every node in the graph is identified by a Boolean. Essentially, it could be an integer, a bitwise mask of 7 Booleans. All right, so each position is 7 Booleans, and then you add in the next thing in the graph, right? And if you detect a cycle, that's your repeating pattern. And then you can say, okay, well, once I've reached this point in my chart, I have this repeating pattern, so I know this is going to happen. And so you just chunk that over and over up to this many pieces. Unfortunately, I'm not going to have time to finish this right now. I didn't realize it was already 7 a.m. I've already been going for 2 hours. So I do have to, unfortunately, stop here. But that's my plan. Yeah, exactly. I'm going to use a byte, so I'm going to use a bit mask to track my 7 Booleans. All right. This is a fun puzzle. The second one is tricky. But I'm pretty sure my thought happens. So I have a graph, and then I detect cycles in my graph. And that might be more overkill, but then that makes it so I don't have to do anything special. But yeah, I'm gonna have a graph. Okay. All right, Smab. And anyone else who happens to be here, my Twitch says there's quite a few people watching, so thanks for hanging out. Sorry, I'm not gonna finish part 2 on stream today, but have a beautiful day. I hope my high level strategy makes sense to people watching. Have a beautiful day. Have a wonderful weekend. Happy day 17, and of course, you're welcome back anytime. I'll be back tomorrow morning. Feel free to follow if you want a notification for when I'm going to be on. All right. Bye-bye.